Okay, in this video I'm going to explain how we can solve the AX equals B problem using the matrix inverse approach. So, as you might recall, the inverse of a matrix, say we have a matrix A, the way that we denote its inverse typically is by putting this little -1 superscript. So this doesn't mean take everything in the matrix and raise it to the -1 power. It means that this matrix is actually the inverse of the A matrix. And its property is such that when you multiply A by its inverse, you get the identity matrix. So just like if typically when we talk about scalar values, so some value x, the inverse of x is 1 over x, so that when you multiply them together you get 1. So the matrix inverse is the analogous operation in linear algebra. So the basic approach to solving an AX equals B problem, like I have here, where we have some coefficient matrix A that stores the coefficients to our set of linear equations, multiplied by the unknowns vector, or the solution vector, is equal to some constant vector. Well, what we can do is I can take and I can multiply this equation on the left side by the inverse of A, if I know the inverse of A. So what I get is A inverse times A times X. If I do it to one side, I also have to do it to the other side, and I get A inverse times the B matrix, the B vector. So these two, A and A inverse, combine to become the identity matrix. And we know that the identity matrix times anything is just itself. So this is actually just X. So now I have X is equal to A inverse B. Like this. And so that's our solution. It's how we would use the inverse of our coefficient matrix to get a solution for the AX equals B problem. Now, I'm going to demo this in another video of how we could actually do this for an example problem using MATLAB and Excel. But I'd also like to just remind us the general process if we were to do this by hand. So if I had a matrix, say something like this, 5, 3, -1, 1, -1, 2, and 1, -8, -1. If I wanted to find the inverse of this matrix, what I would do is augment this matrix with the identity 1, 0, 0, 0, 1, 0, 0, 0, 1. Think of this as kind of one big matrix. And then I would do row operations until I could eliminate these lower triangular components. So I would want to eliminate these components, make them all zeros, and then also all the upper triangular components above the diagonal, make them all 0, and then only be left with the diagonals with 1s. So essentially I want to manipulate this so I get the identity matrix on the left hand side, so that the identity matrix shows up here on the left hand side, and then whatever is in the right hand side over here is going to be the inverse of A. So this is going to be the inverse of A, okay, once we're finished. So I'm not going to actually walk through this example by hand because it takes a long time and it's not very fun. It's much just easier to let a computer do it. But just so that you know how to do it. Anyways, so maybe I'll use this as an example, this matrix, when I show how to do it in MATLAB and Excel. So we'll see you guys in the next video.